So we've talked about the stress strain curves before, so let's go a little bit more on how to read it. So this is the stress strain curve for a ductile metal. This is typically what you'll see, at least initially, in a material science course. With the stress strain curve, you've got the elastic region and the plastic region. The elastic region, you can see it's linear. We treat it like a spring. That's the reason why you've got the stress is equal to the Young's modulus or elastic modulus times the strain. And when you strain the material in the elastic region, it goes back to its original shape. So similar to what would happen with a spring, you kind of pull it and then you release it and it goes back to what it had been before. In the plastic region, you will strain the material, you start to plastically deform it, and then when you release that strain, it won't go back to its original shape. You will recover a little bit of the elastic strain, but you won't recover everything. With the elastic and plastic region, there is a point called the yield stress or the yield point, where that's kind of that transition. And it's hard to see exactly where it stops being linear, so especially with ductile materials, we do this thing called the 0.2% offset. So we take the Young's modulus, because it's just the slope of that elastic region, and we offset it by 0.2% for the strain. And we just draw a straight line, and where it intersects with that stress strain curve, that is the yield point. And that is the point that we don't want to exceed when we're designing materials, and actually most of the time when you're designing material or picking out a material for an application, you have a safety factor of 2 or more. Most of the time you'll be like, okay, well, if I'm going to have an application that has requires 50 megapascals, I'm going to pick a material that has a yield point of 100 megapascals so that I know it won't even get close to yielding. If you want to learn more about material science, remember to like and follow.